Good morning and welcome to today's Solving Puzzles with Python. Let's have a look at today's puzzle. Standard exam type question. Train 1 is travelling at 25 kilometers an hour. Train 2 at 30 kilometers an hour. They are travelling towards each other on the same single line track. Currently they are 100 kilometers apart. Calculate from the current position how far train 1 will travel before the collision and how long it will be before they collide. The answers are to be in kilometers and meters and hours and minutes. So we have to calculate distance and time to that resolution, meters and minutes. So without further ado, let's head over to Replit and start writing some code. So here we have the variables we're going to use. The total distance is 100 kilometers. The answer we're going to give has to be in meters, so we need to convert kilometers to meters, and to do that we simply multiply by 1,000. The speed of the first train, we know it's 25. The speed of the second train, we know it's 30. We don't know, and that's what we've got to work out, is the distance travelled by train 1. And while we're at it, we may as well calculate the distance travelled by train 2, before they collide, that is. By having train 1 and train 2, we can check our answer a little bit. T will be the time calculated by the computer. We need to display or work out the hours and then the minutes. So to do this, I've decided to do a for loop. So here's my line introducing the for loop. I put a print statement in there so we can debug it and see how the code is progressing through the program. For x, which is the counter, in the range of 0, so it's going to start from 0 and it's going to count up to the total distance. The total distance is 100 kilometers times 1,000 meters. So it's going to go through 100,000 iterations of the loop until it runs out. 100,000 iterations will be enough for us to discover when the two trains are going to meet. Now at each cycle of the loop, each iteration of the loop, each click, we're going to calculate the distance travelled by each of the two trains. So the distance travelled by train 1 will be the click in question times the speed from here, and the same for train number 2. The distance travelled by train 2 will be the click in question times the speed. That will give us more than enough resolution or accuracy to discover when the two trains are going to crash into each other. We don't have to worry about the speed in terms of hours. We're just worried about how far they're going to travel before they meet each other, before they collide. Now within our loop we need to determine whether or not the trains have hit each other. We can do that by working out if the total distance travelled by the two trains equals the total distance of the journey. So we have an if statement that's within the loop. We're still running within the loop, so on each cycle or each iteration of the loop we will check the distance travelled by train 1 and the distance travelled by train 2 and see if they come to the total distance travelled. If they have, we know that they must have met each other. We've got a print statement in there so we can debug and see how that program is progressing, telling us to break from the loop, because once we've determined that the two trains have met each other, then we can break out of our loop. we don't have to do any more calculations. So we can break out of the loop at that point. Next we can put in a print statement, and the print statement will display the distance travelled. The distance travelled by whichever iteration we've broken out of. For train 1 is, and it'll print out the distance travelled by train 1 there. And train 2 will appear there. We're using this format of using the curly braces and then the dot format. It's a modern way of doing print in Python. It allows us to control what we print as well. I've got integer dt1 and integer dt2, so we're printing out the whole numbers only, which should give us enough precision. We're already working in meters. We don't need anything less than meters. So let's try that and see what sort of result we get. Okay, that doesn't look too hopeful, does it? We took 99,909 iterations, and if you add these two together, they don't come to 100 kilometers. What could have gone wrong? Well, here we're determining if dt1 and dt2 are equal to the total distance. If they don't equal the total distance, they don't land exactly on the total distance, then it will just keep on going. And that seems to what happened here. Configurations and numbers won't always add up. We need to get to 100 or 100,000, and we can't land on that exactly using the numbers we've got. So we need to catch that, and all we'll say is that it's greater than or equal to total distance. So that will catch if it actually equals the total distance or if it goes past it. Obviously, if it's gone past the total distance, then they must have collided. We're actually detecting, a couple of meters after they've collided. Let's try that and see if we get a better sort of result. There we are. That looks a bit more hopeful. So it only cycled through 1,819 clicks to get to a result, iterations to get to a result. What we have is 45 kilometers, 475 meters, and then 50 by train 1, traveled by train 1, up to the point of collision. And then here we have 54 kilometers, 570 meters, traveled by train 2. Now that is pretty close, but actually it's not quite good enough, because if you add these two numbers together, we're going past the point of collision by a few meters. That's because we're not actually landing on the total distance. We're actually going past that point, and we're going past that point by a couple of meters. We need to wind back a little bit or compensate for the fact that we're detecting the point after the trains have collided. So let's increase our resolution a bit and see if we can come to a slightly more accurate. So instead of doing it in meters, let's multiply it by 10. Let's just put 10,000 in there. So we're up to decimeter, I think 10 centimeter resolution, which is well within a meter. Now, because we're multiplied that by 10, we need to divide by 10 somewhere. So the distance travelled will be divided by 10 here. So we can put divide by 10 here, and we can put divide by 10 here. So that should bring us back to meters. So let's run that and see if we get a more accurate result. There we go. That looks a bit better. So we've now got accuracy of 1 meter. So 18,000 clicks, because we've increased the resolution by 10, but we've divided by 10 when it comes to the distance. So we're at 45,455 and 54,546. So we are out by 1 meter by rounding up. By rounding up, we're just out by 1 meter overall, which is within the resolution of the answer. So that bit's sorted out. Now we need to go on to calculate the time it took for train 1 to meet the oncoming train 2. So to calculate the time, put a print statement in to break up our answer so we can read it, make it a bit more readable. Print what we're going to print out, again makes it a bit more readable. Now for the time it took. So the calculated time, the raw time, will be the distance travelled by train 1 divided by 1,000, because we've already brought it back to 1,000 here. We brought it back from 10,000, so it was originally 10,000. We brought it back to 1,000 here, and now we're bringing it back to kilometers, whole kilometers, divided by the speed, because the speed is in kilometers per hour. Okay, so we have brought it all back into kilometers an hour. We can print this out to see what it looks like. So let's have a printout. So we'll print out T, and it should give us the decimal time it took to reach that distance, 45 kilometers at 25 kilometers an hour. Let's run that. Took 18.1 hours, which is obviously incorrect. If it's travelling 25 kilometers an hour, in 2 hours it will cover 50. So it shouldn't be 18. It should probably be 1.8. So looking at this, that doesn't alter the variable. So we start off with 10,000. We divided by 10 there, but that hasn't changed the value of dt1. Okay, so we're still working at full resolution. So instead of dividing by 1,000, we need to divide by 10,000. And if we do that, that should come out at 1.8, which is, there we go, a lot more realistic. As we've got 1.8, 1 being the whole hours, we can convert that decimal time to extract the hours by just using int t. The integer, pull out the integer from time, and that will give you the hours. The integer will be 1, and that will be 1 hours. So hours is the integer from t, and that goes in there, and the format there. Now we want to convert the 8182 into minutes. So we can take the raw time t, pull out, extract the hours, and that should leave us with the decimal. And the decimal you multiply by 60 to get to actual minutes, 60 minutes in an hour. So 818 or 0.8.81 multiplied by 60 will give us the time in minutes. And that's all in that print statement there. So if we run that, there we go. So 1 hour and 49 minutes, 6 8 of 48 plus a decimal there. That looks to be right. 1 hour 49. So distance travelled by click or iteration 18,100 is 45 kilometers 455 meters for train 1, and for train 2 it's 54 kilometers 546 meters, and 1.8 minutes elapsed, 1.8 hours elapsed before the collision occurred, and that's 1 hour 49 minutes. Once you've created this engine, of course, you can change it to anything. You can change it to 200 kilometers and speeds of 33 and 47 and run it, and it does a whole calculation. There we go. It took 25,000 iterations to discover where the collision, and 82 kilometers by the first train, 117 kilometers by the second train, and that's about right. There's a lot of difference in the time there, and it took 2.5 hours, 2 hours 30 minutes for the collision to occur, and that's it. We have a nice flexible bit of coding here. We have input statements here, we have processing here, processing for the for loop and the if statement, and then we have the output here, input, processing, output, standard structures of a program, and we have altered this program to reflect the precision which we need the answer to be in. And that's it for today. See you next time on Solving Puzzles with Python.